show you my own codes of or my code about um, how I create tables and all that and proper with students, right? And yesterday I'm gonna I issued this query yesterday. Drop drop schema. Now drop is a DDL statement. Right? We'll talk about drop later, right? Drop is a DDL statement, and the reason why I dropped this schema is because I have it before, right? I had the schema before. The name of the schema or the name of database or schema, right? We'll talk about that now, right? Is HR. I've created it before, but I had to drop it so that I can recreate it. Are you following me? So when you have a object, right, that you want to create, and maybe the object exists already and you want to drop it and recreate it, you just drop the schema, right? When you drop the schema, then it says drop schema if exists HR. That is, you drop if it exists, right? After you've dropped it, then then you run what? Then you create what? You create schema. So if I run the schema, forget this quality. The quality here is just saying just telling me the national language support. That is the kind of environment where I'm creating. Just forget about this, right? So if I say create schema HR, right? Basically that's the statement, right? It's just like create database HR, right? This time around I'm saying create schema HR, right? If I run this, hold on. Right, today I want this class to be more practical than what we've had, so that we can understand all the things that we. Oh, my. So please get your machines on. Get your machines ready. Get your workbench on as we proceed with class today. All right. So while my workbench crashed, while my workbench comes on, right? So today I want us to look at the create table statement and how we alter tables, right? We have a lot to cover that we have missed, right? So we'll use the create table statement, then we'll use the alter table, then we'll also create other database objects, then we'll also alter other database objects, right? So basically, this is our agenda for today, so that we can reduce the workloads that we have missed from last class and all, right? So we'll try to cover up what we were supposed to do yesterday and today together. Right? That's what we want.
Sir, sorry. Were you able to go through the codes we did yesterday? If there was anything wrong with it, or it's like you said, we're not. It's because they've not created tables, or there's how you put it yesterday. We created the tables, but it wasn't running, especially for the referencing.
Don't worry, I'm working on it. Right? Most of you, what I've seen so far is that most of you have had issues with referencing. Right? That's basically where most people had issues with the referencing, or just creating
Yes, I had the same issues.
creating foreign keys. Don't worry. We'll look at them today. We'll look at a few of them. If how to do that properly today. We'll look at how to do that properly today. Don't worry. All right. Can you see my workbench, please? Can you see my workbench?
Yes, sir.
Awesome. Now, if you look at it, I have HR now. Can you see? I have HR now. HR wasn't there before, right? So I'm going to delete it again, and I'm going to drop it again, and I'm going to recreate it, right? So that you can follow. I'm going to drop it again, and I'm going to recreate it. So I'm dropping HR now. Can you see? I say drop schema if exists HR, right? If I run this, right? If you look at it, HR that was here before is not here anymore. Can you see? HR that was here before isn't available here anymore, right? Now, what am I going to do? I'm going to create the schema now, right? I'm going to just create the schema, right? If you reload this part, you see that I have my HR again. Can you see? But it is empty. There's nothing inside of it, right? Now, the next thing is I want to select the database I want to use. We're going to create what? I'm going to use HR, right? I'm going to use HR. So now we're inside the HR schema, right? Inside the HR schema. Now, the first tables, I'm going to be creating a few tables, and we're going to create them together. I'm going to share you this code eventually so that you can see them, right, and use them. I want you to create the same exact database that I have, right? So we're going to be creating the first table. The first table we're creating is the regions table. Please, I want you to go along with me gradually. The regions table, right? So create regions, and can you see the bracket? Our creating bracket. What we are going to
we should be doing exactly what you have here.
no, don't do it. I'm going to share the code with you eventually. Don't worry.
Okay.
I don't want you to lose focus, right? While trying to copy the code, right? I'm going to share the code with you. Let me do that now so that everybody can have the code. Let me share the code now. I'm trying to share the code with you. So, all right. So you can download the code on WhatsApp. Right, the code is on WhatsApp. You can download it and open it in your workbench so that you can have exactly what I have. You can have exactly what I have. Right. So we're going back to the workbench. So I'm creating a table called regions, right? And if you look at it, inside of that is you have the regions ID. Now you have init. Init here I'm saying is the length of 11. And I say unsigned. Now it says unsigned is a data type attached to what? To integer columns, which means it does not what allow negative value, cannot contain negative what values. Only non-negative values are allowed. That's the essence of the unsigned, right? And it says the maximum range with unsigned integer is from 0 to 42 million, no, 429 million, 496,000. Wow. It's 4 billion actually. 4 billion, 294 million, 967,295, right? So you can have 1 to this number to about 4 billion, right? You can have 1 to what? 1 to 4 billion and plus, right? So that is the essence of unsigned, right? So when you say it is unsigned, it means that that table or that column cannot contain negative value. And of course, it has a range of this set of numbers, right? So that is what you have. And of course, you see, we're adding not to that, right? Then you see region name. Can you see region name? I said VACA 2, right? VACA 2 and then 25. And I said I'm adding a primary key to the region table. Can you see? A primary key to the region table. Now, if I run this, if I execute this, what happens? The regions table gets created. It's as simple as that, right? The regions table gets created. Don't mind the error. It's just a warning. It's not an error, right? It's just a warning. It's just not an error. So if you click on the regions table, can you see that is the regions table? So if I come down here, please let me know if I'm too fast. If I come down here and I say describe, can you remember describe? DESC regions, right? If I describe regions table, what happens? This is what you have. Right, can you see? It gives us a full details of the structure of the regions table. Can you see region ID, IT unsigned, I mean in it, int unsigned, then the column is does not allow not null. I mean does not allow null value. And it's a primary key table, right? A primary key column, sorry. Then we have region name, varchar 2 or varchar 25, and this allows what? Not null, right? So that is we creating the regions table, right? Then we'll go to the next one, right? Then the next table I want to create is a can you see what I'm creating is a countries table. So I'm creating a table called countries, and it's also having to carry a country ID, and this country ID is what we're using character that is star of 2 lengths. That is each data inside of it will only have 2 lengths, right? And it's not null. They have country underscore name, which is varchar 40. Then can you see country ID? Can you see country ID? Country ID in it, same definition as the country as the country ID that you have here. Can you see? Same definition. What does that mean? It means that the country ID is going to be a foreigner on this table, right? Unsigned and not null, right? Same, but we did not add the foreign key to it, right? Why didn't we add foreign key to it? It's because we just created the table above, and we are just creating this. But you see how to add the constraint afterwards, right? So if you look at it, we're adding primary key as well to country ID. Can you see? So if I run that, all right. So if I run the countries table, right? I've created the countries table. Can you see? The table is created. So if we reload our schema here, can you see region ID, regions table, countries table, right? So what do you have? If we describe that as well, right? If we describe countries, what do we have? Can you see? Can you see? So we'll go to the next one, right? Not to waste our time, we'll go to the next one. It's a bit longer. And this next one, what are we creating? We are creating locations table, right? Locations table, which going to have location ID, unit 11, unsigned, not num. And it's,
Sorry to cut you here. I can't see your screen.
oh, hold on, let me check. Okay, I'm going to represent my screen. I just stopped it. I'm going to start presenting again. Please let me know if you can see my screen now. Can you see my screen now?
No.
Can everybody see my screen? Can everybody see my workbench?
Can't see it though.
Yeah?
I can't see it.
Can another person see my workbench?
I can't see it also.
Please let me know where you can see my workbench. Can you see my workbench now?
I can see it, sir.
Okay. Waiting for confirmation from others. I know, can you see my workbench now?
No, not yet.
Not yet.
I can see it now.
You can see that. I know you can't see my workbench. Log out of class and log in again. Log out of class
Okay.
and log in. Can you see my workbench now? Can you see my workbench now?
Yeah, not. I'm just seeing the Microsoft Teams, the different the chat and all that.
Can you see it
Or
now? Can you see the workbench now?
no, no.
Can you guys see my workbench now?
Yes.
No,
Yeah? I can't hear you.
I can see it now.
Okay. All right. So going back to my code, right? So now I'm creating locations, right? I'm creating locations. Locations ID, can you see? Locations ID, data integer length 11, unsigned. Remember, unsigned is that it does not allow for negative value, not null, and auto increment, right? Street address, virtual 40, postal code, virtual 12, city, virtual 30, not null, right? State province, virtual 25, country ID, virtual 2, not null, and primary key on the locations ID, right? Primary key on the locations ID. Now, if you notice, all the columns that I'm creating, the first value or the first column, all the tables I've created, the first column is usually the primary key column, right? The first table on the table, the first column is usually primary key column, right? So that is how that is done, right? So if we create right? So now I've run that statement now, right? If you come here now, you see locations. Can you see? Locations has been created as well, right? So if you describe it, it's going to give you more. We describe, right? So if we describe locations, right? What do you get? You get this view of the locations. Can you see? You get this view of locations, right? So you get this view, which we call the structure of the table, right? Describe gives us the structure of the table. Not to waste time, we'll move to the next one. We're creating, so that's the fourth table that we've created. I mean, the third table that we've created. So we want to move into creating another table called the department table, right? Department ID, integer 11, unsigned not null. Now you should know this by in your mind now, right? Without looking at anything. Department name, virtual 30 not null. Manager ID, unsigned. I mean, yeah, you need int 11 unsigned. Then locations ID. Right? Can you see locations ID from the locations table? Can you see this locations ID is coming from the locations table, right? So you see it says what integer 11 on what unsigned. Then we are putting a primary key on the department ID column. So if we run this now, what do we have? We have department table, right? Department table is has been created. Can you see this is the department table, right? So we have two more tables to create. Can you see the jobs table? Create table jobs, job ID, voucher 10, not no. Job title, voucher 13, not no. Minimum underscore salary. 8, can you see decimal? We're using decimal now. Decimal is saying that we're using a length of 8 and a precision of 0. That is, nobody has a salary that has decimal. That's basically what you're saying. If I put 2 here, means that your salary can be 5,070 kobo, right? 5,070 cents, right? $5,000 70 cents. So depending, right, we can say, so we say 0, that's and is unsigned, which does not allow negative value as well. You cannot have a negative salary. Then we have max underscore salary, which is decimal data type. Same thing, 8 length. So the highest length of salary that you can have is the 8 digits for salary, right? The way we say it in Nigeria, job role, labor market, or whatever they call it, right? A precision of 0 and primary key on the job ID column, right? So if we create this as well, what happens? That table is created as well. If we reload our schema, you see that under the HR table, we have 5 tables already: countries, department, job ID, locations, and regions, right? And regions. Now, the last one we want to create is the employees table, right? The employees table. And the employees table is the table that contains the details of all employees, like the employee ID. These are the attributes. Employee ID. So you have int 11 unsigned, not null. You have first name, voucher 20, last name, voucher 20, not null. That is, everybody must have a last name, but it's not compulsory for you to have a surname. It's not compulsory for you to have a first name, right? Like people from Korea who do not have first name, but most of the time they have all the time they have their last name. Then we have email address, which is voucher 25, not null. We have phone number, voucher 20, which contains value. Remember that if you do not have not null in front of the column in the definition of the column, it means that the column can contain null value, right? So you can phone number, email address is compulsory, and phone number is not compulsory in this organization, right? That's company policy. Higher date is date, and what? And not null, right? It's date. Higher date is date. And remember, for the date format on the system, on the database, the date format on the database is date format on database is CCYYMMDD, right? So take for example, today's date is 19th. So we say 2021 0919, right? This is the date format on the database, right? On the database, on MySQL database, right? So that's what you have here. So whatever date you're using must follow that format. Then we have job ID, voucher 10. Right now, if you look at this job ID is coming from what? From the jobs table. Remember, we created a jobs table. I remember this ID. If you click on column, can you see this ID here is the same ID that you want to have here, right? Then we have salary. Salary is now look at it from also this column. Your salary is decimal 8 precision of 2, not null, right? And in the job history table, we have minimum salary, maximum salary. So which means that this data here, right? This salary column here is further divided into minimum and maximum salary on this table. I follow. That's what you see as we proceed. Then we have commissions per percentage, which is decimal. That is, if you collect commission. Hold on, please. Hold on. All right. So salary is further divided into these two minimum and maximum salary on this table. Then we have commission. Commission is decimal, and it contains just two, which means that your commission cannot be more than two digits in decimal. I mean, 2 digits and 2 decimal places. So you can't have 1 point. You can't have a 3 digits commission percentage, right? So you can have something like 05.10, right? So that's what you have here. Then we have manager ID, which is also coming from the employees table, right? And you'll see as we'll deal with all of them later. Then you have the department ID as well, coming from the department table, right? So a whole lot of the IDs from these other tables are coming into these employees tables. And of course, we are creating an employee ID, right? We are creating a primary key on the employee ID, right? So what do? We align everything, right? And we run it, right? It's running. Can you see? Now it has been created. So if we select that, right? Can you see? So now we have created how many tables? 1, 2, 3, 4, 5, 6 tables, right? We've created 6 tables. 6 tables in total. Yes, and we have the last table, which is the job history table, right? We're creating a job history table that contains information about the history of employees' job role in the company, right? So we have create table, job history, right? Employees ID, init, 11, unsigned, not null, start date, the date the person started, the date the person end date, right? Job ID, job ID, voucher 10, this is coming from the job table. The department ID is also coming from the department table. Can you see? Right. So if you look at it, the only table, right? The only table that that does not have a primary key, right? That does not have a primary key here is this table, right? Because it does not have an identity or a candidate key of its own, right? Employees ID is coming from the employees table, so that will serve as the employee as its primary key, right? But it can be duplicated. And what does that mean? It means that if Vivian joined the organization as an HR, are you following me? She's holding she's joining the organization. She joined the organization as an HR expert, right, or an HR consultant or HR staff, right? And she held that position for 2 years. And because of the fact that she has started doing data science or data analytics, right, she discovered that the organization has an opening for a data analyst, right? And she applies internally. What happens? Her job history changes from HR to data analyst, right? Now on the job history table, right, she would appear twice. That's what that means. She would appear twice, right? So which means that her ID, if her ID is employees 100, employees 100 would appear twice on that database or on that table, which means that the table can allow for duplications of value. That's why we do not have a primary key on that table. And every other table, except for the start date and end date, every other information is coming from several other tables. You have job ID and department table, right? So that is also, we're going to create this and we're going to run this. Please let me know if you understood how we have created all these 7 tables put together, right? How we've created all these 7 tables put together. Please let me know if you understood that before I proceed.
So I have some questions.
Okay.
Okay, first off, in the previous classes, you said for integer, there is no need for us to assign numbers.
Yes.
For a length.
Yes.
Because that's the latest trend or that's the standard now. So
yes.
I don't know why we still have to assign.
Well, I assigned it because of classes, so that you know that it is possible that you can put a length to your integer. But it doesn't mean that if you remove the length, it will not work. Do you understand what I'm saying?
Okay, sir. So the second is the second one you talked about. The second one you talked um about for this create job history, that if somebody moves from one department to the other, how is the person, how are we going to, if we are to create the double database that you're talking about, how are we going,
Double
where is,
data. We're not creating double
no,
database.
sorry, like for the
The
employee
double, the
ID
double information on that table.
information, yes.
Yes. How do
Okay.
we create it?
Yeah, from the, is it already created in this create table job
No.
history?
The table is created. We're saying that if we are to put information into this table, the information in that table can be duplicated. That's why it does not have a primary key. Do you understand? The information there can be duplicated. That is, Vivian with the employee ID of 100 can appear multiple times, right? You understand that people stay in an organization for 10 years, for 25 years. I've seen people stay in an organization for 35 years. Now, in 35 years, they would have changed job role maybe 5 times, maybe 7 times, maybe 3 times, right? Now, if they change job role, this table contains every single time they change a job role, their information is inserted into this table. That is the essence of this table. Anytime they change a job role from admin secretary to HR, their information change that this person did admin from so time to so time. That is the start date and the date that ended. And the person took a new job role as a data analyst from so date to so date. Do you understand? That is the essence of that table. That's the essence of that table. Please let me know if you understood what I just said.
Yes, sir.
Awesome. Awesome. Can I move on, please? Can we move on? Any other question? All right. So, can you see my PowerPoint? Can you see my PowerPoint? Please let me know if you can see my PowerPoint. If not, let me know as well. Now, before I begin to show you more things, right? Before I begin to explain other concepts, right? Now, if you look at it, all of these tables, right? All of these tables have been created. All of these tables have been created. But if you look at it, we have not added foreign key to any one of them. We have not what? Added foreign key to any one of them. And this is the reason, right? Which is why you guys have issues when you were. I knew you were going to have issues, but I just wanted you to see it so that you can understand, right? When you are creating a table, right? Now, usually, all the tables have to be created, right? And the columns, as you want them to be referenced, right? Although not referenced, but say for example, we have job ID here, we have department ID here. All of that has to be created, right? Once you have done that, once all of that has been done, you can now begin to use the alter statement. After now, the essence of you creating your table and not putting foreign key is such that the values you want to insert your data into the table, right? You want to first of all create the table. Now, you have not learned how to insert data, but the challenge that you have with referencing is that you are referencing a table and a column that does not exist yet, right? And even if they exist, right, the data inside of them has to match. And because the data is not there yet, the essence of the primary key and the foreign key is that whenever they are created, they have to juxtapose themselves. They have to make sure that the values are the same. Take for example here, location ID. Location ID or department ID is a foreign key, and it is coming from the locations table. That is, the ID on the locations table must be the same as the ID on the as the locations ID on the department table, right? So as to not to have issues, right? So as to not to have issues when creating them, right? What we do is that you delay creating your references, right? You delay creating your references until when you have populated the table. When you have populated the table, right? What happens? You can now begin to use the alter statement. Let me show you where I did all of that, right? Can you see? Can you see? Alter table. Please let me know if you can see my screen, right? Alter table countries, add foreign key. Can you see? On this, can you see? This is where I referenced all the foreign keys. Can you see? All of them are foreign keys. All of them, right? And I'm going to teach you how to do this as we proceed. I'm going to teach you how to do this as we proceed, right? So, and the reason why I did is so that I do not have the error that you guys have. I hope you're following me. I do not have the errors that you guys got, right? So that is why we are what? That's why we created that way. That's why we created that way. Awesome. Now let's continue, right? Olade, welcome. Madam Anita, welcome. Right. Please let me know if you can see my screen. Please let me know if you can see my screen. Right. You also talked about constraint already.
Yes, I can see it.
Awesome. Awesome.
My network was messing up.
All right. Now, so we've talked about creating tables, how to create tables. By now, I want to believe everybody knows how to create tables. But we've also talked about how to create what constraints are and how to create constraints both at column level and at table level, right? Now, we want to talk about alter table, right? How do we alter a table, right? Which I just showed you an example of now. How do we alter a table? How do we alter a table? What does it mean to alter a table, right? It says use the alter table statement to add a new column, right? So you have created a table, right? You only alter what has been created, right? Make me sound as if I'm a pastor now, right? You only alter what? You can only alter an existing what? Existing table or an existing object, right? You can only alter an existing object, right? So which means that when we want to make changes, right? When we want to make changes to an object on the database, what do we use? We use the alter what? Alter statement. That's what we do. We use the alter statement to make changes to objects that already exist, right? So, and I'm going to show you how to do that. So you say add what? You can add, using the alter table statement, you can add a column. You can modify an existing column, right? You can define a default value for a new column, right? You can drop a column and you can rename a column. Are you following me? Right? So you can watch. You can, with alter table statement, with the alter table, you can do what? You can add, you can modify, you can rename, and you can what? You can drop. Right? And of course, define a new what? You can define a new value, a default value. Sorry. You can define a default value. Right? We're going to see all of this. Now it says after you create a table, you need to change the structure. You may need to change the structure of the table or the table structure for any of the following reasons. You omitted a column, right? So maybe you omitted a column, right? You don't have to recreate the table entirely. What you do is you add the column that you omitted. Your column definition or its name needs to change. Say you want to change the name of a column or the definition of the column. When we talk about definition of column, we are saying that the name of the column, the constraint on the column, the data type of the column, all of this makes up the definition of a column, right? The definition of a column is made up of the name, it's made up of column name, right? Data type, and constraint, right? These three makes up what? Makes up your column definition, right? So when you want to change your column definition, you also use alter table statement. Then you need to remove columns. You want to delete columns. We also use the alter table statement to do that. If we can use it to add, then we can use it to subtract. Now note, the alter table statement is the DDL statement, and hence it is auto commit. Remember, I've said it before, and I'm saying it again, that DDL statement are what? Auto-committed transactions. DDL statements are auto-committed transactions. That is, you do not have to save them out by yourself. The system saves them automatically, right? And let's see a few examples of the alter statement, right? Let's see a few examples of the alter statement. Now, I'll show you a few things, right? Now, it says use the alter stable statement to add, modify, or drop columns, right? So you see the syntax of what that looks like, right? It says the first or last column name, that is when you use first or last column name, specify, helps you to specify the position of a new column in a table. We're going to see how that works. Don't worry, right? You can add a column after an existing column, that is using the after column name, or you can what? Or as the first column, if you omit this clause. It says if you omit this clause, the column is appended at the end of the column list to a table. Now, basically, this is what we're saying, right? So take, for example, right, just look at me. So I'm creating a table called alphabet, right? I'm creating a table called alphabet, and this table has the following columns: B, C, E, F, G, right? So I created these columns inside this table, right? I created these columns inside this table. Then I now realized that, oh, I omitted A. Are you following me? I omitted what? I omitted A. What do I do? When I'm adding A through the alter table statement, remember we alter the table when you forget or when you want to add a new column, right? When I'm adding A, so I say alter table, add column A. I'm going to show you, don't worry. Add column A. Now I can say add A as what? First column. If I say add A as what? First column, what happens? A is what? Brought to the front as the first column. Now, if you look at it, so you have added A, B, C. D is also missing. So we want to add D, column D, right? I can say add what? Add same way, add column D after what? After column what? Column C. After column C, right? So what happens? D is added to its place. So we use the first and after, right? The first or after to order column arrangement. If you do not specify first or after, what happens? The column is appended or added at the end of the list. What does that mean? It means that if I do not specify their position, right? If I do not specify their position with first or after, like we did earlier, right? The column will be added like this. Will be added. So A will be added here, and D will be added what? Will be added here. Are you following? A will be added after G, and D will be added after A, right? But with first and what? With first and after, we're able to move A to its right position and D to its right position, right? Or to its rightful position, right? So that is what all of that means. Now look at this. Look at this, right? And we're going to look at a few examples, right? We're going to look at a few examples. Now we're going to look at a few examples now. Alter table. So we're altering the table called departments, right? So I'm going to quickly create a department table, a depth table, and we're going to alter that table, right? So let's look at it. Let's go back to my workbench. Please let me know if you're following. Please let me know if you're following. Please let me know if you are following.
Sorry, sir. There's a part network they allow me to get. When you want to add the column D, right? You should say alter, then
Don't
is
cram
it
it. Don't worry.
before?
You will see it. You don't worry. You don't need to cram it, right? You will see it in action now,
Okay,
right?
sir.
You don't need to
Is
cram it.
it? How do you write the statement? Is it before column
Don't worry.
uh,
And like I said, you will see it in
B
action.
or before column C? I didn't see where you did it.
I've
I
not.
knew how you did the A, but I didn't know how you did the D. You did
That's what I'm
the
saying. You will see it. You will see it now. Don't worry. You'll see it. Right? You'll see it.
all right,
Awesome.
sir.
All right. So we want to. I'm going to come here. I'm going to say use. Let me see what database I can use there. Don't want to mess up my age database. My HR database. Sorry. So let me see. Oh, Okay, yes, we have. So I'm going to say use XYZ, right? Use XYZ. So I'm using XYZ schema now, right? And I'm going to describe, so XYZ has a table called department or depth table. So I'm going to look at it. Created that table a while ago, right? So you see, department ID. So the table contains 4 columns: department ID, department name, department email, and region ID, right? Region ID. So now the business case is that add the following columns to the depth table. Location ID. What do we add again? Let's add, what do we have in rows? Hold on. Okay. Let's say location ID and location name, right? So we have created the table already. The table exists already, and we want to add locations ID and locations name to the table, right? Remember that we are dealing with alter table now. I hope you're following me. We're dealing with alter table now. We're dealing with alter table now. Right. So I want to write an alter table statement. I want to create another table statement. Hold on, coming. All right. So alter table depth. Sorry, alter table depth. Right. Now, what do we want to do? We want to add. Right. Remember, the statement says add the following columns. Right. Add. Right. So add what? Add. What column are we adding? Let me show you so that you see. Now, can you see this? Add location. Then the same way we created them is the same way we're going to add them, right? Add location underscore ID, right? What is the data type in it, right? 11, right? Will it contain null value? Not null, right? Now, where do we want to add it, right? Where do we want to add it? We want to add it after department email. Please, are you following me? Are you following me, please? Right. So, want to add it afterwards, department email. Can you see? I need you to follow me. I need you to follow me so that we can. Right. So, I'm just going to say, eh?
we're following you.
Awesome. So, we say afterwards, not no. I say afterwards, after department what? Department underscore email. Right. So the table has been altered. Can you see? The table has been altered. So let us investigate if locations ID was added after. If it was altered, if the table depth was altered, if locations ID has been added, and if it was added after what? Department what? Email. Now remember that this is the department. Can you see? Can you see my cursor? Department ID, department name, department email, right? So if I reload that, can you see? Locations ID is after department email. Let me bring it out for you to see. So you say describe depth, right? You will see that locations ID is after department email. If I did not put after, it was going to come after region ID, right? But because I put after, what happened? It went straight to where I wanted it to be, right? Now let's write another alter statement. The statement asks us to add two column, right? So we want to add a location's name now, right? So we say alter table depth, right? Can you see that is English language, right? Add location underscore name, right? What is the data type? Varchar or varchar 40, let's call it, or varchar 25, right? And I'm saying it should come after, right? Come afterwards. Not null, sorry. Not null. Then afterwards, location underscore ID, right? After location ID. We select all of these and we run. Right? And we describe the table, the table again. What do we have? Can you see? Both of them are after department email. Can you see? I specify that location ID should come after department email. And I specify that location name should come after location ID. Are you following me? So that is how we alter a table, right? If I alter a table now, let's see. Let me add. Let me alter the table again and add another column. Alter table so that you can see what I'm talking about. Alter table depth, right? Add region underscore name, right? Varchar 25. Not null, right? Not null, and without location, right? Without specifying where I want it to be. Where does it go to? Right. So it has been created, it has been altered, table has been altered. If I run that, can you see? By default, it goes after. It goes as the last. It comes in as what? As the last column name. Comes in as what? As the last column name. And that is how you alter a table, right? I hope you understand what I'm saying, right? That is how to. I've showed you how to alter a table, right? How to alter a table and add a column. How to alter a table and add a column. Any question, right? The next one we want to look at is how to modify a column. We've added a column. Right? How do we modify? How do we modify? Want to modify? That is, want to change what already exists there, right? How do we modify? Are you following me?
Sir,
Yes, I can hear you.
so when do we use unsigned?
When do we use unsigned?
Yes, sir. And then
We use,
if it's for the first one, if you want to add it at the first place, you just put first.
yes. If it's going to be the first column, you just, instead of after, you put first. Are you following me?
Yes, sir.
Right? Uh-huh. Unsigned, like I said, unsigned is a is like a data type that we use for integer, right? For integer data type. And what that means is that we're telling the integer that it can only contain positive values between 0 and 4 billion and so that figure I gave you the figure up there, 4,200,000 and something million 900 and something thousand 900 and something, right? That is what you are telling that this data type that I'm creating must essentially majorly what you are saying to unsign, what you are using unsign to say is that it must not contain negative value.
So that means we can use it anytime we just want to assign a non-negative value.
You are
Even
going to
here,
use it with the integer. You are going to use it with the integer. With the integer, anytime you are using integer data type, this data type like this now, I can come here and say unsigned, right? Even though I didn't, right? I come here and say unsigned. You see what I just did?
okay, sir.
Exactly. All right. So,
Sorry, sir. One last one. Sorry, please. Number 12. There's some sort of asterisk on it. When I was doing the last assignment, I was just getting something like that,
now,
even when my code was right.
anytime you get this, right, don't you can just put your cursor on it, right, and see what it's saying. Let me see if that solves it. Right. Most of the time, it's a compiler error, right? It does not matter as long as your code is right. It does not matter. Can you see that it didn't stop my code from running, right? Take for example, from here, I'm trying to see why it is. It might just be. It's not a major. Of course, it can point you to a major error, right? It can point you to a major error, but in this situation, it's not a major error. It's saying that there's a problem. That's why it is underlying alter. It's saying that there's a problem with my alter. Let me do this. Right, it's still there. Right, it's still there. Right. Basically, the code is right. Once the code is right, this might not be a problem. Usually, when you have when you don't end your command or your statement with a semicolon, is when we get it. But I don't know why. Hold on. Let me check something. Right, it's still there. Somewhere, hold on, I know why. Yeah, that is why. Usually it is because of the I didn't add semicolon to the end of my program. That is why it is giving me that. Can you see? Can you see that it's back? Right. So, but it does not stop. Now, the reason why it does not stop is that it does not stop your code from running because we are in an editor environment, right? That these rules you can escape the rules like not adding a semicolon at the end of your program or at the end of code. You cannot do that in what's it called? You can't do that on the command line interface. You have to terminate your code with a semicolon at the command line interface. But in this environment, right, you must. It's not compulsory, right? But it makes your code cleaner, right? It makes your code cleaner and neater, right? That's why we use them. That's why we use them. I hope I understand. I've answered the question. So take for example here now.
Yes, sir.
If I had it now, sorry, if I had it, that should disappear. Sorry. Can you see? It's disappeared. So I don't have any red asterisk anymore. Of course. Now we want to talk about modifying, right? Modifying. How do we modify? Right. So it's the same statement, alter table, right? Depth. Alter table depth. Now modify. What do we want to modify? Right? Let's say that I want to change. I want everybody to look at locations, right? Okay, I want to put location ID. I want to give it a length, right? It didn't have a length. I want to give it a length. So what do I say? I say locations underscore ID, right? Int and length of 11, right? I close that and I say not null, right? I say not null, and I close that statement, right? If I run this, look at it, it didn't have a length before. If I run this now, right? It's giving me a warning. It's giving me a warning. So if I describe depth again, Hold on. Integer. Well, integer will not show actually. Let me use a better. Integer will not show respective. Let me change the name. Um, um, let me change. Which one does not have? All right. So we said that department email is does not must have the department must have an email. Let's change that. Let's change that so that the department does not need to have an email. I say department underscore email. So no value, right? Let's see. But hold on. Let me describe this a little bit again. Let me describe this. Department email is 40, so I'm going to change it to virtual 50. Right, I'm going to change it to virtual 50. I'm going to run it this way. Awesome. So it has executed. So let's run department. Let's describe depth again. Awesome. Look at it. Department email was virtual 40 before, but now it is virtual 50. Can you see? And before it does not accept no value, but now it accepts no value because I've changed that from no to yes. How did I change this? Remember that I did not even specify anything. I did not specify that it should not contain no value, right? I just omitted that not null constraint and it modified the table. Are you following me? I omitted the not null constraint in my description of the table, right? In my description of the column, sorry, in my description of the column. And it what? It's changed the length of the data type and it removed what? Not null constraint from the table, right? If we come back again and say, change this to 60, right? Or let's change it to 30, and we say not null. Now look at it, not null is yes now, right? Can you see not null is yes in this part? Can you see? But if I run this now, you see that not null will be modified something else to no, right? Can you see? It's now 30 and not null is what? It does not allow for what? No value. Can you see? So that's why I say no, 0, no. Before, I changed it from no to yes. Now I return it back to no. So that is how to modify, right? That's how to modify. Let's see what we can modify again. Integer basically, like I said, in the new versions of MySQL, right? Integers does not have length, right? They don't. Their length does not show, right? Their length does not show because by default you're saying that the integer can contain values from 0 to about 4 billion, right? So the length really does not show in the table description like we have it here, right? I'm trying to see what we can edit again. Now let's modify. Sorry, let's modify. Let's assume that people. Let's say that we have a business case that says um, um, users are complaining about the location name. So shorten the location underscore name column. Right, shorten the name, shorten the location underscore name column to loc underscore nm, right? Loc underscore nm, right? So how do we do that? We say alter, right? Can you see alter table depth modify, right? Modify coming. Sorry, not modify. Rename Done. Come in. All right. Rename location underscore name space loc underscore nm. What's the column definition? Batch 25, and it's not null. All right, so you look at it. We've shortened the name of location underscore name to loc underscore name. How did I do that? Alter table depth, change column name. Can you see? Change column name from location underscore name to loc underscore name. So this is the old name, this is the new name, and I gave what the table what description, right? Now, if I describe that table again, you would see that it has changed from loc underscore name to, location underscore name to loc underscore name. Can you see it? Can you see it? I need a response, please. Can you see it?
Yes, sir.
Awesome. Awesome.
Yes,
So,
sir.
so that is how to shorten a name. Now, take for example, we have another business case that says change the name of the debt table to department table, right? To department, right? Change the name of the table debt to debt table to department table. So how do we do that? We say alter table debt. Are you following me? Are you following me? Other table debt. Rename. Yeah. Rename to department. Right? Rename to department. Right? If I run this now, what happens? It's executing. That's been executed. So if you reload this now, you see that the depth has been changed to what? To department. Can you see? So if I say describe depth, right? If I say describe depth, it will give me an error to tell me table does not exist. Can you see? Table xyz dot depth does not exist, right? So if I say change that to department, it will give me that as my result because we have changed the name of the table from depth to department. Please let me know if you understood all that I just explained. So we have done, we have added a column, we have modified a column using modify. We have also changed the column name, and we've renamed a table. You see how powerful alter statement is. You see how powerful other statement is. It gives you total control on your database object. And we're going to see it not just on tables, we're going to see it on several other database objects as we proceed. Right? Now,
Sir, I have a question. Quick one.
please. Okay.
Okay, so I noticed when you wanted to change for column, you say change column name. When you want to change for table, to rename, then you use rename for table. What if you want to change for maybe a whole database, or let's say an object? Is it still rename you use?
When you want to change what?
Possible.
When you want to do what?
Change like a database name, like this XYZ. If we want to change the name, is it possible to change the name? And what statement are you going to use?
Okay. Let me answer your question. Coming. Hold on, please. Actually, what we do to rename a database is that it is almost impossible, right? Let me say impossible to rename a database. Are you following me? And that is because databases are very unique, right? They are very unique in their ways. They are very unique in their ways, right? To be able to rename a database, we have to drop that database, right? Which means that which is what we did in the very beginning, right? In the very beginning of my code here. We have to drop that database, right? And the reason is because basically the way the database is referenced. Hold on, let me show you. Right? When you create a database, right? When you create a database called XYZ, right? And you under that database, we created a table called departments table. We created another table called maybe locations table, right? Now, these tables are of course, that's their name. But if any other person wants to use these tables, they refer to, first of all, the database name XYZ dot department, right? Dot department. So when we change the name of a database, right? Basically, what you are saying is that you are changing the configuration of your database, right? And it's usually a very, very tricky thing to do, right? And that means that what it also means is that you are trying to edit the structure of your database. You're trying to edit the data dictionary. That's basically what you're trying to do, right? But it doesn't mean that it is not doable, right? It doesn't mean that it's not doable. Usually, I do not advise it, right? I do not advise that, but let's try. You need to have the root access to be able to. Let me see some. Just hold on. The alter schema, right? Alter schema XYZ. Rename to ABC. This is going to work. Right? Even MySQL does not allow us to alter.
So, even I asked because I encountered such problem the first teachers. I tried to even delete the entire database and recreate another one. Once I recreate the database, it will still bring the same name that I created previously, even though I've dropped it.
No,
so I was confused.
no, this is it. So um, dropping a database, right? Dropping a database, like I said, is not as simple as this. I mean, renaming a database is not as simple as this, right? That's why I wanted to run it so that you can see that it is not as if is I'm trying to run away from the question, right? It is not as simple as changing the name of an object, because the database name, what you're trying to do is that you're trying to edit everything that we do, edit the data dictionary, right? I remember that I told you guys that the data dictionary is the database of the database itself, right? But this is like you're changing, it's like somebody coming to change your name from Vivian to Funke, right? You have to go through several court processes and all of that, right? And that's the way it occurs on the database, because every object on the database, especially when it comes to schemas and the database in a data server, they are very, very unique, right? Now, to be able to rename, right? To be able to rename would need usually the fastest way to it is you drop that object, that is, you are deleting that object to recreate it. Are you following me? Now, when you drop a database object, every component inside of it is also dropped. So it is very, very difficult. And you cannot easily just go and change the name of a data schema, because why? These schemas are logical partitions. They are logical partitions, right? These schemas are logical partitions, right? Registered in the control file. They are logical partitions registered in the control file. So it's a bit more technical, right? So but the fastest way to doing it is to drop it. You drop that table, or you drop that schema, and you recreate it, right? Now, you said that somebody taught you and you try to drop it and you try to recreate it and it's coming back with the name. Now, usually, right, if you do not have the permission to drop a table, you will not be able to drop a database. You will not be able to drop that database, or to drop a schema. You will not be able to drop the schema, right? And also another challenge that can be is that if you are fetching that data back from your backup, if you have a backup of it and you're trying to fetch it back, it would usually come back with the same name, right? But basically, when you drop an object, right, you can rename a new object the same name, because what that means is that name is no longer available in your database, and another object can get or can take that name, which is what we did here. Let me show you. In the beginning of this class, I came to this data and I said, I have HR schema before, and I said the drop schema. Can you see if exists? Drop schema if exists HR, and the schema dropped. Then I recreated it. That is the only way. Are you following me? That is the only way to how do I put it? To rename a schema, right? But once you have created a schema with a name, basically that is the name that you're going to use, except that you are able to edit some certain part of the data dictionary, which I do not want to go into. It's a bit more technical than what we're trying to do, right?
Okay, sir.
Yes.
So, I'm really sorry I'm asking too many questions. So this HR that is in small letters, if you actually want to put it in capital letters and
You have to drop it.
alter it,
You have to drop it.
because I did mine and after I dropped, I tried to recreate again and it's still bringing it in the small letters instead of capital letters.
No. It would not now. And another thing that you should know is that database schema names cannot be in capital letters. Let me show you.
Sir.
Schema names cannot be in capital letter. Let me show you. Right? If we say create schema, right? Create schema DFG, right? Let's call it DFG capital, right? Create schema DFG.
Excuse me, sir. Sorry.
Yes, ma'am.
Excuse me, sir.
Yes, I can hear you, ma'am.
You are saying create schema. Create schema and create database. Are they the same thing?
Yes, they're the same thing. They're the same
Okay.
thing. Let me open a new data query. I say create DFG. Right? If we reload in this place, can you see? Can you see that I created it in capital letter, but it came in small letter, in small letter.
Okay, sir. Wow.
Do you understand? Yeah.
Yes, sir.
So now
Thank you.
this kind of object now, if I want to drop it, I will just drop schema, right? Drop the schema. Right? Can you see? It is gone. Can you see that it is gone? Can't
So,
find
sir,
it.
why do we add if exists?
If exists is to say that if it exists, drop it. Now I'm using if exists because I want to create. Now I used if exists in that situation because usually I'm supposed to run all of this at the same time. Do you understand? I'm saying this is a two statements, but I'm running at the same time. Drop schema if exists and create schema HR, right? Drop schema if exists HR, then create immediately. Right. Don't worry, you understand it when we begin to talk about create and replace. Don't worry, you understand that.
Okay, sir.
Yeah.
Okay, sir. Thank you very much, sir.
All right. All right. Um, so basically, that is what we have. So we've talked about renaming, using the alternative statement to add a column, add a column to your table, modify the content or the structure, a column or whatever on the table, shorten the name of a table using what change column, specifying the old name and the new name, then renaming the name of a table itself, renaming the name of a table itself, right? So that is essentially how alter table works, right? That's essentially how alter table works, right? Now,
Excuse me, sir.
yes,
Sorry, sir. You said that when we want to create a database or schema, we should not use capital letter. So anytime I
I'm not
want to
saying
create
you
a
don't use,
database,
I'm not saying you should not use capital letter. If you use capital letter, it's going to bring the name back as small letter.
okay, okay, thank you.
That's one. All right. So the last thing we want to talk about is drop, right? How do we drop? So let me describe my table again, my department table. So I'm describing the table again, and then there's a particular column there that I do not need anymore, right? So I want to drop that column. So I can say also the business case is drop the look underscore nm column as it is no longer needed. So how do we do that? We just say alter table. What's the name of the table now? Departments, right? Drop column, right? Then you specify the name of the column. Look underscore nm. Right? If I run this now, that gets executed. If we go back and describe that table, you see that the location, the look underscore nm column is gone. Right? Basically, that is how to drop a column. That's how to drop a column.
If I understand you right, sir, that means if you want to now drop and recreate, that's when you use the if exists. So once it drops the first one, it will now recreate to the second name you're renaming it.
Now you use drop, and that is when you are creating a whole object, right? You're creating a table, you're creating a view or a schema and all that, right? But for dropping a column, a column is a subset or is an object of a table. You cannot use if exists.
Okay, sir.
You cannot use if exists. Also. All right, so alter table, modifying multiple columns at the same time, right? It says the alter table can be used to add, modify, and drop multiple columns at the same time, right? So let us look at this example. Same way, add what? Multiple columns to a table. Alter table depth. Add manager, ID, not null. Add region. integer, not null, right? We are adding, so you can add multiple columns at the same time, right? Then you can what? Modify multiple columns at the same time, right? Let's see an example of that. Let's see an example of that. Let me see what we have here. All right, so I'm trying to look for a table that I can easily use. Okay, let's go back. Let's continue with our XYZ. Right. So now we want to alter and add multiple columns, right? So business case is what do we do now? Department table. They say add the following columns to the department table. Manager underscore ID. Manager underscore name. Right? So we want to add these two columns to the department table. So what do? We say alter table, right? What's the name of the table? Department, right? Then we say add, right? Manager underscore ID is init, right? Init. I'm not going to give it a value. I can say unsigned, not null. Every department must have a manager, and that's all for that. Then we say add manager underscore name, batch 25, right? Not null, right? Awesome. So if we run this now, can you see? Statement executed. So we say describe department. What happens? The two columns are added. Can you see? The two columns were added instantly, right? So you can use alter table to add multiple columns, right? If you have 10 columns, 20 columns to add at the same time, you can do that. Then you can also use it to modify, right? So you can say alter alter table. What's the name of the table now? Department, right? Modify. What are we modifying? As let's change. So let's change manager underscore ID, the long name, it's too long, to manager underscore ID, right? Change column manager underscore name to mgr underscore nm, right? Run this. Sorry, manager underscore ID, not manager underscore ID. it. Incorrect integer value. Sorry. Name Pacha. Pacha. All right, can you see? So I've been able to use the order table to change the name of two columns, manager ID to MGR ID, and specifying the description, and change the column manager name to MGR NN, right? So basically, you can do multiple columns at the same time. You can use it to drop multiple columns. Can you see? Multiple columns and all of that. So you can do a whole lot with that. You can do a whole lot with that, right?
Sorry, excuse me, sir.
Yes, ma'am.
Please, can you explain that unsigned?
I've explained unsigned before. I said unsigned means that you use unsigned with, we use it with integer data type, and it means that you are saying that this unsigned means that the data type does not contain, would not allow negative value. Unsigned means that the int is like a data type. It's a data type on its own, right? And it means that that column must not contain, must not allow negative value. Do you understand?
Yes, sir. Yes, I do. Thank you.
That's it. All right. So you can use the other table to also drop multiple columns, right? You want to drop multiple columns. Let's see that. Let's drop multiple columns, right? Copy. So alter table. So drop column, drop column. This is their old name. We'll remove the old name. Manager ID. Remove this name as well. We don't need their data types. Also, we're deleting them off. We don't need their data type because we're dropping them off. So if we run this now, those columns will be dropped, right? If I describe departments again, what you get, can you see? They are gone. Manager are gone. Those two columns are gone, right? So that is how to use that's how to use them to change. So we've used them to change columns, and we've used them to what? To drop column as well. Use them to drop column as well, right? We've also talked about renaming a table, right? We've talked about renaming a table. Now, the next thing we want to talk about is to truncate a table. What does truncating a table means, right? Now, remember that we're talking about DDL statements, right? We started with DDL statements in our list of SQL statements, DDL statements. And in the DDL statement, we said that there is create, which we've talked about. We've used it to create just one database object, which is tables. We'll still use it to create views and some other objects, right? We've talked about alter, right? And we use it to alter what? Tables. We also still use it to alter views and some other objects, right? Then another DDL language that we've looked about is what? We've looked at rename, actually. Rename, although works with alter, right? We've looked at renaming a table, right? We've looked at that. Then we want to look at truncate, right? We want to look at truncate. And what does it mean to truncate a table? So we have truncate, We've looked at drop as well. We've looked at drop. We've looked at drop, which also works with alter. And the last one is comment. Right? So we've looked at create, we've looked at alter in respect with, we've looked at alter, and we've looked at rename in respect with alter, with respect to alter. We've looked at drop with respect to alter as well. So we have truncate and comment to talk about. So we want to talk about truncate now. And what does truncate do? It says truncate is the truncate table deletes the content of a table without the structure, with the structure, the table structure intact. It works like delete statement without a where clause. It is an auto comment what statement. So let me explain what truncate means to you. So when you say you truncate a table, right? I think truncate is also an English word, right? Let's assume this is the table and I have data inside this table, right? I have data inside this table. This is the ID, first name, last name, email, right? I have A, B, C, D, E, F, G, H, I, J, K, and L, right? J, K, L, right? Now, when you say you truncate a table, right? Now, two things are here. We have this object is made up of two things. This table, a table is made up of two things. One, the structure. Two, the content, right? So when you say you truncate a table, what you remove is the content of the table, but the structure of the table will still be intact. Now, I'll say that again. When a table has is made up of a table consists of two things, right? The structure of the table, right? And the content. Remember that so far we've created several tables, but we don't have content in those tables because we've not added content to them. But those tables exist, but they don't just have content. So let's assume that we have a table, which we're going to see. Let's assume that we have a table that has both structure and content. We have a table that has both structure and content, and you truncate the table. What you do, or what you have done, is that you delete all the content. You are removing all the content of the table, but the structure of the table would exist, will continue to exist. Now, what does that mean? It means that if you allocated 5 MB to that table, right, and you remove the content of that table, this size that is allocated to that table is not released for use anymore. Remember, when you delete something, it's supposed to release a space. When you delete a movie from your system, what happens? The space that movie occupies is released for reuse, right? But in the situation of a truncate statement, the space is not released for reuse because the table still exists. What does not exist anymore is the content inside of it, which means that you can reuse that table. You can reuse the structure of the table with another content. Are you following me? That's what truncate does. That's what truncate does. Let me look for a table that we can easily truncate. Hold on. Select all from T. Let's see if it has content. Nope, not it. All right. Just hold on. I'm looking for a table that has content here. I think I should have one. Students. All right, so this table has this data. It has matric number 101, Olalekon Joshua, phone number, email address, course, and department, right? If I truncate this table, I say truncate. Right? So the table has been truncated. Let's read from the table again. Can you see? Can you see what just happened? The structure of the table still exists. Matric number, first name, surname, phone number, email address, course, and department. Can you see? They are still there, but the Olalekan, the two rows that were in that table are gone. What we've just done is that we truncated a table. Please let me know if you understood what I just explained. Please let me know if you understood what I just explained. I'm waiting.
I understand, sir.
Hello, sir.
Yes, ma'am.
Okay, you say when you truncate the table, it means that the column will still be there, but the rows will disappear.
The structure of the table is still intact, but the columns, I mean the rows, the content inside the columns are gone. So in this case, from what you can see on my screen, A will go, B will go, C will go, D will go. All of those content is gone, but the structure of the table would remain intact.
Okay.
Yes.
Thank you.
All right. Are we there? So we're in chapter 4 now, creating views, sequence, and index. Creating views, sequence, and index. What says the time? This is 5:24. Do we need a break? Do we need a break, or are you good to go? Can I continue? I need responses quick, please. Do you need a break, or should I continue?
So if you ask me, let's continue so that we can finish up by 7. I don't know for others.
All right, I need to hear from others. John, I'm not saying anything.
Let's continue, sir. Let's continue.
All right, let's continue. I have to. Let's continue.
We didn't have the class yesterday.
Yes, exactly. All right, all right. So, right. So, we want to look at. We've looked at or we've talked about database objects. Now, remember that I told you that what the most popular database objects are tables. Database objects, right? We've talked about tables. I told you that there are tables. We have tables. We have views. We have sequence. We have indexes, and we have synonyms. Right? 1, 2, 3, 4, 5. There are several other, right? You have database link. You have triggers. You have procedures, and so on. Several others, but all of these are more advanced and they're not very popular, right? They are used by developers who want to develop stuff on the database, right? But the most important ones are the ones we want to talk about. That is table, views, sequence, indexes, and maybe synonyms, right? So we want to talk about, so chapter 4 talks about creating views, sequences, and indexes, right? So we want to take them one after the other. What is a view? What is a view? It says a view is a virtual table. Now, from the word virtual, I want you to put this down. The word virtual. The word virtual means that it does not really exist, right? It does not, the virtual here means that it does not really exist on its own, right? It does not really what exist on its own. It does not really exist on its own. We're going to talk about it briefly, and when we get to DML, we'll go back to views, right? So if a views are virtual tables that do not store any data of their own. Can you see? A view does not exist on its own, right? But displays data, so it does not have any view, does not store any data of their own, but display data stored in other tables, right? It displays data stored in other tables. In other words, right, it says views are nothing but SQL what queries. A named query stored in the database what catalog. Don't worry about the plain things. I'm going to explain what it means. It says a view can contain all or few rows from a table. It says a MySQL view can store data from one or many tables. A view is used to simplify complex queries. It also adds extra security level to the database. Now, what is a view? Let me explain, right? Don't mind that plenty story. A view is a database object that is used to store just SQL queries, right? Just SQL queries. And when we talk about SQL queries, we're saying that you queried something from the database. You sent a question to the database, and the database gives you a reply, and you want to store the reply as an object. Then you create a view. Now, so what does that mean? It means that a view does not have data of its own, but it relies on output from several tables, a table or several tables. That means that for you to get a view, for you to create a view does not exist on its own. It is dependent on one or more tables. That is, you can create a view on one table, or you can join multiple tables together to create a view. Are you following me? So a view is a database object that does not exist on its own, but relies on the information from other tables. Do you understand? Now, it says that it is used to simplify complex queries, right? And when we get to joining, I will explain that word, complex queries, right? When you say that you're driving complex queries, say I'm joining 5 tables together to get information from it. Like I showed you in last class, right? That you can join I think last week, that you can join multiple tables together, right? Using your foreign keys, right? And I showed you the AR diagram and all that, right? And when you have complex queries and you want to store that information, what you do is you create a view. That's one. 2, let me give you a practical example to what a view is, right? When you were creating your account number, or when you're creating your bank details, right? When you're creating an account, when you're opening an account in say GTB or whatever bank that you have, they store you have your account number, your name, your phone number, your email address, your phone or your house address. If you have what's it called? If it's a corporate account, you have references, your BVN, your NIN, even your credit card, your ATM pin is on it, your password is on it, your CCV is on it. It's all of those informations are generated for you, right? But when you go to an ATM, right? When you go to an ATM machine, what happens? The only information that the ATM machine asks from you is when you insert your card. Do you want to perform a transaction? Do you want to perform a withdrawal? You say yes. Or do you want to check your account balance? You say yes. Then he asks you, is it a savings bank? Is it a savings account or a current account? Then you select. Then if it's a withdrawal, it asks you for what? For your for the amount that you want to withdraw. Then after that, it asks you to put your password or whatever it is. Then it gives you the money, right? Why didn't it ask you for your CCV? Right? Why didn't it ask you for your credit card? Right? Because the database that the ATM uses is not the full database of the bank. Why? You are using a GTB bank card on a Fidelity ATM, right? What they do is that they create a view, right, that replicates some columns from the main bank account table. That is, all the columns that they deem fit not to be not to be threatening, right? Not to be threatening. Images, information that are shareable, that even if an hacker begins to sit in between, right, would not really have anything to make out of, right? That's the kind of information that they share. Are you following me? And we use that as security. let me expand that a little bit for you so that you understand what I'm saying. So imagine that you started work today as a database administrator for, or as a data analyst or whatever it is, right? For, say, InterSwitch. And we all know that InterSwitch has people's credit cards, right? Where they store credit card numbers and all that, right? And of course, for you to be able to, that kind of information, credit card informations are very vital information, right? Which means that they are very, very, very security level on that kind of information is high, right? And you as a newbie that just joined the organization, do you think that they will put you straight to the database that has people's credit card, right? They don't know if you are a thief from where you are coming from, or if you are an hacker or something from where you are coming from, right? And you begin to imagine that they allow you access to those kind of information, and before you know it, you tap into maybe Dangote's credit card, and you begin to shop, or a billionaire somewhere, right? Now, what they do is they want you to work on the database, but they don't want you to see sensitive information. So the way to keep sensitive information on a table away from people who do not have the privilege to see them is through a view. Are you following me? So we use views as an extra security level on databases. So if I have a table that contains very, very high profile information or security information that I do not want every user on the database to see, what do? I have to create a view on that table that has a subset of the information that I feel that they can see, and I hide away the ones that they cannot see. That's the essence of a view. So how do we create a view? We use the create or replace view to tell the server to create a view object in the database named what? View underscore name. And the as select statement is the SQL statement to be packed in what? In the Microsoft views. It says it can be a select statement that contains data from one or multiple tables, right? Now, we'll talk about views much later, especially after we've discussed DML statement. But I just want to introduce you to what a view is, right? I don't want to just jump into SQL select statement because I'm talking about the view. So we'll be creating a view much later, right? But just understand, views are created based on data from another table. Views are dependent on tables. Now, we want to talk about indexes and how to create indexes. We want to talk about indexes and how to create indexes. Right. So, question is, what is an index? Right. And index are what used to improve performance of query by quickly the larger the table, the slower the search, right? The larger the table, the slower what? The search, right? So what exactly is an index, right? And let me explain. I'm going to try and explain an index in such a way that you're going to understand it once and for all. All right, so one talk about indexes, right? I'm just going to put that here. Index, right? So what we talk about index, we're saying that the function of an index is to improve query performance. The function of an index is to improve what? Query performance. So what exactly do we mean query performance? Now, let me use a real life scenario for you before we will bring it back into the database, right? So everybody went to a university, one university or the other, and in the university you have a library. Now, university libraries are usually very large libraries, right? Like for my own university, right? My own university, we actually have one of the biggest library in Nigeria, right? So, and imagine a university that has maybe about 13, 15 faculties, right? And you can imagine imagine number of departments that you have in different faculties and all that, right? And you as a medical student or you as a computer science student, you need, say you need a book called SQL, my SQL, right? You need a book called MySQL, and you go to the library, right? And all the books in the library are just piled upon each other, right? They are just piled upon each other, right? So you have something like this. You have a pile of all of these bin books, right? All of these bin what? Bin books. Just a pile, an heap, right? A heap of books. And this is you here, right? What happens? You are looking for a book called what? MySQL. In this A stack, what happens? It's going to take you, maybe if you're not careful, the whole semester or a whole section, or even not, your whole 4 years or 6 years that you want to spend in school, in looking for a whole book. So what did the university librarian does, or what do they do? What they do is that they now create a shelf, multiple shelves, right? And on those shelves, they begin to divide those shelves into what? Into categories, and they name them. So they say medicine, right? Then they put the books for medicine here, right? Then they say geography, right? And they put geography books here, right? They put geography books here. Then they say art, right? Then they put art books here, right? Then they say somewhere here computer science, right? Then they put computer science books somewhere around there, just like this, right? Now, you are looking for computer science, you're looking for MySQL, right? Now, it will be wrong for you, of course, to go and look for MySQL in medicine, because MySQL is not a medical book, right? So what do? You go straight to computer science, the computer science what section, and what you find MySQL book there. In fact, what they do again in the computer science section, let me expand that a little bit. Let's clean all of this up. What they do in the computer science section is that in the computer science section, this is the computer science section, right? This section has become this section, right? Now, in that section, what they now have is they now have shelves, right? They have shelves that now contain several books. So you have A, you have B, you have C, you have D. So you have E, you have F, G, H, I, J, K, L, M, N, O, and P, down like that. So all the books that has their name starting with A are stored in this place. All the books with B, all the books with C, and down to M, where you have MySQL. So which means that when you go to computer science, when you go to the library, you don't need to search the whole library. What you go to is you go to computer science. Yeah, right? You go to computer science. Then at computer science, what do? You look for what? What is the starting letter of the book you're looking for? M. Then you go to what? The M section in computer science and begin to what? Look for what? MySQL there. What has that done? That has made your search for the book what? Improve the search for the book very fast. Because why? Indexing has been applied, right? It's the same thing that actually happens when you go to a shopping mall, right? Say in Nigeria, we have shopping malls like ShopRite, or if you travel abroad, maybe Walmart, right? Right? And you go to ShopRite, and when you get to ShopRite, what do you see in ShopRite? They don't just put every goods together. What do? They have sections for each of their products, right? They have sections. So you see the grocery section, you see the kitchen section, you see the body cream and all that section, you see the drink section, you see the flour section, you see the wine section, You see all of those sections, right? Which means that if you are looking for a body cream or you're looking for an hair cream, you don't go to the wine section. Are you following me? That is indexing. And that's the same thing that happens in the system. Even God created us with an index, even though the world is trying to, blur the line around the index that God created. God created us male and female, right? Of course, Google has made us understand that presently there are over 70 plus gender recognized by Google, right? And that's what forms the whole LGBTQ environment. Beautiful for them, right? Now, right? But basically, structurally, we are created as male and female. So you see a male, you know this is a male. You see a female, you know this is a female, right? And that is the way God has created it. And why did God create that? That is indexing. Such that if I go into a room where there are people, I can easily identify those who are male and those who are females, right? So you go to the university, and 90% of the time, when you see a student wearing white and black, you can easily see or tell that this is a law student. Because why? There is an index on them. Law students wear white and black. Are you following me? When you go to the university and you see a student wearing lab coats, right? Wearing that white overall, right? There's about 100% chance, right, to say that that person is in the science field. Because I don't think people in art or in social sciences or in commercial or whatever they call it, right, uses lab coats, right? It's only people in the sciences that uses that white lab coat. So that is indexing. It's easier for you to find things out with index, and that's why we say that they improve query performance. And it's the same thing that we have on the database. When you have a database that has data that is about, maybe you have about 25 rows. I mean, you have about 25 columns. You have 25 columns and maybe about a billion rows. Right? Don't even let us use a billion. Right? Let's say you have 25 columns and you have 200 million rows, right? As Nigeria is 200 million people, right? Even though statistics says that we're still about 189 something million people, right? But let's say 200 million people, right? 200 million people. So we're 200 million people, and you have 25 rows. And in these 2 million people, you are looking for Agbata Vivian, right? I am sure that on the database, right, there are several Agbata Vivian, maybe 1,000, maybe 500 people, maybe 700 people, maybe 1,300 people. But more than one person probably bears Agbata Vivian, right? If your name is not like my name, Akintubo Oluwaseun, I can doubt it. I can bet it. The people bearing that name in this country are not very plenty. If I thought there is any, maybe one or two, right? Because that name Akintubo is not popular, not a general name, right? I'm not saying Agbata is general. I'm just saying, right? So don't let us use Agbata. Let's use a more popular name, right? There are popular names in Nigeria that you can even find up to 1 million people bearing them. So you say your name is Ajayi Olumide. Hi, see this name? Every Nigerian bears it, right? You are Ajayi. That name Ajayi is, I'm sure there will probably be about 5 million people in Nigeria bearing that, if not more, right? Now, if you are looking for Ajayi and you query the database and you are saying the person's name is Ajayi Olumide and 1 million people, 1 million rows were returned, has that improved your query? No, right? Because what it means is that you still have to search out of 200 million people, you got 1 million people. Now you still have to search this 1 million people to be able to get that single person that you're looking for. It's the same thing that we do on Facebook, right? When you're looking for somebody on Facebook, what happens? Facebook gives you what? It gives you a list of several people. Then you begin to use their pictures, right? You begin to use their pictures to what? To look and see if the person. It takes time. Now, what does the system does? In MySQL, on any DBMS, right? Remember, DBMS are database management system, right? In any DBMS, we use index to improve query performance. Right? We use index to improve query performance. We use index to improve query performance. Right? And there are two types of index. Are you following me? There are two types of index. I hope you're following me. Please let me know if you're following me. Right? Please let me know if you understood all that I've said so far. Do you understand the concept of index now? Please let me know. Please let me know. Anybody, if you understand the concept of index.
Yes, sir, it's good.
Yes, sir. But then, is that not the reason we have like primary keys to identify the particular person?
Now you are getting it. You are getting there. So we have two types of index. So where I explain that, you understand now, right? We have index. We have bitmap index, and we have B-tree index. Bitmap index and B-tree index. Bitmap index usually uses um, colors, right? Hash variable, right? That's what they use. And B-tree indexes uses bitmap uses colors, right? And B-tree uses hash. Um, sorry, hash variables or hash numbers, right? But don't worry about it. Let me just explain, right? Basically, what we do, the most popular one is the B-tree. So I'm just going to clean up the bitmap, right? The most popular one is the B-tree, right? It's the B-tree index. So what is the B-tree index, right? Now, a B-tree index says that if your phone number is 08029321312, right? Let's assume this is your phone number, right? This is an Airtel number, right? Because it starts with 0802, right? It's an Airtel number. I want you to follow me. I want to explain what a B-tree index means to you, right? On the Airtel database, right? On the Airtel database, of course, you know that Airtel has 0802, 0808, 0818, 0812, I'm not sure, 0814, maybe 0902, 0908, and all that, right? Let me mute your mic.
How is it?
All right. So Airtel has this. So this person's number is 0802932131. Now, it will be stressful. So say you are looking for this person on this database, right? Say and Airtel has about 30 million what? Million subscribers, right? 30 million subscribers. And you're looking for just one person. This will probably take time for your system to scan through all these numbers. Are you following me? It will take time for the data server to scan through for the instance to scan through all these numbers to be able to get just one number. So what happens when we add a B-tree index? If we add a B-tree index to this, what happens? This is what you have. So you have Airtel, right? Airtel is now divided into all of these branches. So you have Airtel is now divided into all of these branches. You have 0802, you have 0808, you have 0818, you have 0812, you have 0814, you have 0902, and you have 0908, right? Now, Remember that what we're looking for is 080293212 or 1312, whatever, right? Now, with this formation, you will discover that this is the only place that we need to check. This part is the only part that we need to check. We do not need to come to this place, nor come here, 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 because we cannot find this number in these sections, only in these sections. Why? Because we're using a bitmap index. Now, what does that mean? It means also that in this section, right, we have 0, so 080 is the constant. Then you have 1. So Ether does not have 1. 001. So there is no 1. So we're going to clean that off. Sorry. So Ether does not have, so what is, so 080 is constant. So you have 2, you have 3, you have 002. Sorry, it's 002. Sorry, hold on. So 002 actually is what is constant. Sorry. 002 is what is constant. 002. Let me rub this off since we don't need this. Right? Then what you now have is under 002, you now have 0021, 22, 23, 24, 25, 26, 27, 28, 29. Right? Now, look at the number. So we've gotten that it is 002, right? So we're not coming to any of this. So we cancel our trip to these ones. So then we say it is not 21, it is not 22, it is not 23, it's not 24, it's not 25, it is 29. So what happens? We come straight to what? The query comes straight to what? To 29. What happened? First of all, you have cancelled all the trip to this what? Long journey. You have even cancelled the trip to what? To all these long journeys. So you are concentrating only on 29. Then 29 as well now as 291, 292, 293, 294. And that is how it breaks the number down, such that when it is looking for the number, it goes directly to where the number is, because you have added what? An index on the data. Index helps you to go directly to the data that you're looking for without what? Having to scan through the old data on the database or on a table. Are you following me? You do not have to scan through, so the data does not have to scan through all the data in the table, but it goes directly to what it is looking for, because that data has a marker on it. The data that you're looking for has a marker on it. Also, now, having explained that, right, it says an index is a data structure such as a B tree, which I just explained, that improves the speed. Can you see? It improves the speed of data retrieval. It improves the speed of data retrieval on a table at the cost of additional writes and storage to maintain it, right? Basically, what it's saying is that indexes helps to speed up what? Data retrieval. It says the query optimizer may use what? Indexes to quickly locate data without having to scan every row in a table. Having to scan what? Every row in a table for a given query. It says when you create a table with a primary key index or a unique index, MySQL, automatically, can you see? Automatically creates what we call a special index named what? Primary. This index is called a clustered index. Now, I will explain what that means so that you don't get lost, right? So this is it. How do we create index? That's the question now. How are indexes created, right? Now, there are two ways indexes are created. intrinsically or right? Don't mind my spelling, right? Now, intrinsic means that it is created automatically, right? By the server, by the data server, right? And I'll show you how. Then extrinsic is created, index is created by users, right? Now, let's take intrinsic first. How is intrinsic? Let me spell intrinsic there. Let me change it. It's called spell English. Don't mind me. I'm the one doing stressing myself. I don't implicitly. Yeah, that's what I'm looking for. Implicitly. And explicitly. And explicitly. Right, good. Implicitly and explicitly. Same meaning, right? As intrinsic and extrinsic. Right? So implicit creation of index. Implicit creation of index means that indexes are created automatically. Remember the word automatically. Indexes are created automatically anytime you create a primary key constraint. Anytime you create a primary key constraint, a primary index is created. Are you following me? Anytime you create a primary key constraint, a primary key index is created. Are you following me? Are you following me? So it says that when you create a primary key or a unique key, can you see? MySQL automatically creates a special index called what? Primary. This is a clustered index. Clustered in the sense that it is added when the primary key is created, right? So when you create a primary key in constraint, primary key index is created. When you create a unique constraint, right? A primary, although in advance, let me call it what it is actually. In advance, or not advanced, actually. The right word is, you say a unique index is also created. Right? When you create a primary key constraint, a primary key, I want you to remember that. When you create a primary key constraint, a primary key index, a primary index is created. When you create a unique constraint, a unique index is as well what's created. Now, what does that mean? Remember that anytime we create a primary key constraint, when we say we create a primary key constraint, what did we say about primary key constraints? That is, they are unique. The column would have unique values, right? They cannot be what? No duplication, right? And they are what? Compulsory. These three things are the characteristics of a primary key constraint of a primary key column, right? A column that would carry a primary key constraint must be ready to contain what? Unique values that will not be duplicated, and those values are compulsory. That is, for every observation, for every row, those values must be provided. Now, by the definition of this, right, you will see that the values are unique. Therefore, When you create a primary key constraint, what happens? Every value in that column, right? When you create a primary key constraint on a column, right? Every value in that column is unique, right? Every value in that column becomes unique. And because of that uniqueness that they have, a unique a primary index is attached to every unique value. So that anytime you are looking for a value from that column, they do not the server or the system does not have to scan through the whole table. It goes exactly to that value because the value is unique. So when you are in your university or when Nigeria is looking for the person with the NIN 23456789109, right? What happens? They don't need to scan the whole table. That value is unique to one single person. So when that query would run fast because why? That is the only value. That is the only row that has that value. That is the essence of primary index. Primary index are created whenever you create a primary key constraint, right? Now, same thing whenever you create a unique index. A unique constraint. Whenever you create a unique constraint, right? What happens? A unique index is as well created. Now, what are the characteristics of unique Unique a column that would have a unique constraint, right? They are not necessarily compulsory, but the values have to be what? They have to be unique, right? If they are unique, it means that there's no duplication, right? So the only difference between primary key constraint, a primary key column and a unique key column is that what? A primary key column is not null, while a unique column can be null, can contain null value, right? So which means that anytime you create a unique constraint, the values in that column cannot be duplicated. So it means that for every observation, every row, those values are unique. So you can easily use it to use the data in that column to fetch out that data, right? And what does that mean? So matric number, take for example, no two persons share matric number. No two persons share same student ID or BVN or NIN, right? So if you are looking for the student with matric number 1000, only one person would be returned. Are you with me? The same thing with your email address. No two persons share the same email address. That's why every time you want to create an email address, if your email address exists already, the email server will tell you that that email address already is already taken. Create another one, right? Because no two persons can share the same email address. Those email IDs have to be unique. And if the email IDs are unique, you can use them to easily search for a particular data. When Toyota is creating 2020 Camry or 2021 Camry, they will probably create create 1 million copies or 5 million copies or 10 million copies of it. But you will discover that each of those copies are unique. Even though when you put 2020, 2021 Toyota Camry side by side, you will see that they look the same. Same arrangement, same structure, but they have a chassis number that is unique. Are you following me? They have what is called a chassis number. That is unique to each of them. When you buy a biscuit or a product from the store, right? You buy a bottle of Coke and they all look the same. But in actual fact, each of those products are unique because why? They have a barcode on them that uniquely identifies them. Are you following me? The same thing with currency. Each naira, you see that there's a unique number on it. That means that those values are unique. So you have, when Nigeria was producing 1,000 naira, they probably produced 1 billion copies of it, right? But each of those copies are unique. They are not the same with each other. They are always unique. Human beings, right? we are unique. How are we unique? We do not have the same DNA. That's one. Two, we do not have the same what? We do not have the same fingerprint. Three, we do not have the same dentition. Right? The same. That's why if you look at it, when they are looking for somebody in all of these movies, and the person has died and has decayed, right? And they can't get a fingerprint. What they begin to look for is they begin to look for the teeth of the person, and they do an imprint of the teeth, and you discover that we do not have the same imprint of teeth. Even though whenever all of us smile, we smile with the same caramel or whatever the teeth is made of, but we do not have the same dentition. It is unique to individuals. So that is how we are indexed out in the real world. And the same thing happens on what? On the server, right? Or in a database, right? So it says primary index is special because this index stores itself is stored together with the data in the same table, right? The clustered index enforces the order of rows in a table. That is, when you have an index, when you have a primary index on a table, right? What happens in that table? That table does not contain duplications, will not allow duplications, right? It will not allow duplications on that table, right? And they are what? They are stored on the table. The index is attached to the table. Whenever, now this is very important. You need to know this. It's very, very important. Remember I said there are two ways to create index, right? There are two ways to create index. Whenever you create an index, whenever every index that is created with a primary key, every index that is created with a primary key, remember when you create the primary key, a primary index is created. Every index, and you attach this to a column, right? When you create a primary key on a column, a primary index is attached. That index is clustered. That's why we say it's a clustered index. It's clustered to the table. It's clustered to what? To the table, which means that it is attached to the table. It is chained to the table. Are you following me? It is chained to the table, right? Now, when you create an index, so it's like when you are creating the table, right? The index is part of the DNA of the table, which means that it will be very difficult to separate the table and the index. That's what I'm going to. But when that is an implicit creation. But when you explicitly create an index, right? Explicit creation means that it is the user that creates the index, right? Which means that the table already exists. I have created the table, like all the tables that we've created before. Those tables do not have indexes except for the primary key index. So if like the last table that we created on when I was creating the tables, right? So that table does not have a primary key, which means that at the moment there is no index on that table, right? I can now create an index on the table, right? Which I will show you. I can create an index on the table, right? This is the table, right? In this situation, in the fiber of the table, right? Because when the table was being created, primary key was added to a column. And when primary key was added to the column, primary index was attached to it. So in the fiber of the table, the index is inside the fiber. But in this situation, the index is just attached to the table. So in this situation, the index, as much as is an object, it is fine-grained, it is tied to the object. In this situation, the table is an object, the index is an object. You now join both of them together. That's what you're doing. Right? So which means that this index in the explicit way is easily broken. I can easily break the table and the index. What that means is that if I delete this index, this table will not be affected. Of course, returning queries from it will be slow, but the table structure will not be affected. Now, in this situation, if I delete this this index, right? If I delete the column where the index is, where the primary key is, right? If I delete that column, what happens? The constraint is gone, the index is also gone. I'll take that again. When you create a primary key on a column, right? Remember we said that a primary index is created. Whenever you delete that column, the constraint and the index is deleted. Because why? It is a clustered index. But that's not the case for the explicit way of creating, because in the explicit way, the column is an independent object. The index is an independent object. You are now joining both of them together, such that when you delete the index, right, what the table does is that it just dissociates itself from the index, right? Deleting the index does not affect the structure of the table or the content inside the table. The only thing it affects is the retrieval of queries from that table. Are you there? Right? Now, it says other indexes other than primary index are called secondary index or non-clustered indexes. Right? So how do we create index? How do we create index? We create index using the create index keyword. Can you see? Create index, the name of the index. Sorry. Create index, the name of the index, then what? Sorry, let me clean all that. So we use the create index, then the name of the index, then on which table are you attaching the index, the name of the table, then the column that the index would be on, right? So look at an example. We say create index, right? Look at it, create index, index underscore name underscore IDX. That's the name of the index. On which table? On the department's table. On which column of the department's table? On the department's name column. Are you following me? Right? So that is how to create an index, right? It says to show all index on the table, it says show index from what? From department, right? How do you drop an index? It says drop index, the name of the index on what? On the table. So let's look at that in practical, right? Let's look at that in practical. I hope we're not bored. I hope we're not bored. I hope we are not bored. Please let me know. Are we bored? Are we bored? I hope you're following me. All right, so I'm going to do this, and I'm going to go back to use HR. All right, I'm going to go back to use HR, and I'm going to go to, so I'm going to say HR is available. So which table should we look at? Let's look at show index on employees. Sorry. Right. Can you see? It says that on this table, we have what we call a primary index. Can you see? It's a non-unique index. It's a sequence in index. It is on the employee ID column, cardinality, all of that, blah, blah, blah. Can you see? The type of index is a B3 index. Can you see? B3 index. And it's visible, right? So on that column, we have just one index, right? So I can create an index. I say create index, right? And I say what, hold on, before I create index, let's describe the table. Right, so let's describe the table. Right, so that's the table, right? And I want to create an index on, let's create the index on, let's call the index, create index m underscore, that's the name of the index I'm creating, email underscore UX, right? That is, I'm creating a unique index. Right, on employees, right? What column? The email column. right? Creating an index on the employees column, on the email column of the employees table, right? So right. So if I run this now, come up, the index has been created, right? The index has been created. Now this is an explicit way of creating index, right? So if I come to show index from employees, remember that what we had there before was 1. If I run this now, can you see? Can you see the index that we created? Employee, can you see? Is it a unique index? It says no. Because that's why it says 1. 1 there means no. It is only the primary key that is what? That is a unique index. This is a no, it's not a, I mean, it's not a non-unique, right? It means that it is not a clustered index. It's a non-clustered index. This one is a clustered index. This is not a clustered index. Now, can you see the name of the index? Emp underscore email underscore UX. On which column? On the employee, on the email column. And it's a B-tree index. Can you see? The B-tree index. That is how to create an index. So when I want to search data, now what has this index done? The question will be, what has this index done? This index has now gone into the employee and into the email column on the employees table to put a unique hash value. Are you following me? Are you following me? It puts a unique hash value. You put a uniqueness. A unique is like you put a unique tag on each of the data inside that column, such that anytime you are looking for a value from that column, that value is carrying a uniqueness, and it will be, because of that uniqueness, it will be returned faster in a query. Do you understand? It will help a query run faster. That's basically what an index does. Are you following me? That's basically what an index does. Right? So that is how to create an index. So anytime you create, so when we were creating this, when we were creating primary key, right? Look at this. When we created this primary key on this table, right? It says that what? An index is created. So what do we do? How do we know? If I say show index from countries. Can you see? Primary key. Can you see? It was created when we created that table. When we created that table, that was when that index was created. I hope you understand all that I've said, right? That is how to create an index. So if you want to drop an index, you drop the index by saying, so yeah, we created an index here, right? Can you see? Employee emp underscore email underscore UX. So if I say drop index, right? What's the name of the index? Emp underscore email underscore UK on what table? Employees table.
So I have a question.
Hold on. Yes, what's your question, please?
Sorry, there's a concept I want to actually understand. I want to grab from this underscore email underscore UK. You know, when we're creating the part where we're adding all the keys, then primary keys, foreign keys, constraints rather. Yeah, we did that, but I don't think I really understood how we got the underscore email, or probably forgotten. Then
I'm
what
not
is
getting your
it
question.
like
I can't.
the The create,
Eh?
see where you did create index
Uh,
m underscore email underscore
UX.
ux. Can you explain the combination? I don't really like. I don't understand it.
See the combination, right? So let's do this. Let's describe this table, right? So this table is what is an employees table, right? And the employees table has an email, right? So when I'm creating an index, I'm also creating an index on this column, right? And I said I've told you that what any object that you are creating, you must give it a name, right? And I want to give it a name. And I've told you that what the name of the object must reflect the purpose of the object, right? So how do I do that? I shorten employees table. I shorten the name employees. I called it emp. And I'm saying that I'm creating a unique index, right, on the email column of the employees table. That's basically it. On the employees table, an employees table has a email column that I'm adding a UX to, a unique index to. That's basically it. So I'm creating a unique index on the email column of the employees table. That's it. There's no magic to
Okay,
it.
so the ux is unique index. Then
Yes,
uk is unique key.
yes, ma'am. Yes, ma'am. Thank you. That's what I missed there. I was using UK instead of US on
Okay, that's why I was confused.
these. Right. So if I drop, right, can you see it has dropped? So if I run show index from employees, what you get? Can you see that unique index that we created before has been deleted? That's basically how to drop an index. Basically how you drop an index. Right? Are you following me?
Hello, sir.
Yes, ma'am.
So if you want to create an index, you have to use the syntax show index.
You have to what?
If you want to create an index on any table,
Yes.
you have to use that syntax show index. Because that's
No.
what I'm saying.
Show index is to show the index that already exists on the table. So you want to see the index that already exists on the table. Do you understand? That is how we know.
Yeah.
So if I know
So
the
you mean
index
show
that,
index is referencing the table that is already existing.
yes, this you are saying show index on a table that already exists. Yes. So if you create a table, so take for example, you join an organization today, right? And they want you to work on a particular table to retrieve data from the table. The first thing you are supposed to do is check if there's an index on the table. Do you understand? When there's an index on, so you use show index from maybe the table is enrollees, right? So you use show index from enrollees. If there is no index on it, then you create an index on it so that your query will run faster. Do you understand? All right.
Okay.
Don't worry, people. Wow.
So this one now, this particular one now, you created the index. There was no index on this one.
Yes,
Like,
there was
just
no
ran.
index on that column, so I added an index to it.
Okay, that's why you added the EMP and UX.
What is it?
That's why you added the EMP underscore
Yes, underscore email
with
underscore
the
UX.
UX.
Yes, yes.
Yes. Okay.
Any other question? Don't worry, we're almost done. Even though our way is still far, but at least we're moving. We're in chapter. We're about to go to chapter 5, which will start next class. Right? Chapter 5, chapter 6 must finish. I'll send the second part of the slides to us when I have them. Right. So we're in chapter 5, and we have some more chapters to go, but we're dealing with the most technical part of it, right? So that we can have a smooth ride to the end, right? DML, also we can finish DML, transaction control, and all of that. Finish them, then we'll move to the next subject that we want to talk about, right? So, but we're dealing with the most technical part of it at the moment. All right. So we're talking about creating index, right? It says now creating unique index. It says a unique index is another type of index used to enforce the uniqueness of values of one or more columns. A table can have one primary key with a primary key and with a primary key that comes with a primary index, but unique index can be what? Can be used on one or more columns. Now, what does that mean? A single table. A table can only have one primary key, right? And can only have one primary key, one primary index. I'll take that again. A table can only have one primary key and one primary index, right? But it can have multiple unique keys. That's when I say when I say primary key, I'm saying primary key constraint. So a table can have one primary key constraint and one primary index, but it can contain multiple unique constraints and multiple unique indexes, right? It can contain multiple unique constraints and multiple unique indexes, right? So you can create an index. It says unique index can be added to columns while creating the table. Of course, when you are creating a table, you can add a unique index to it, right? And look at this example. Create if not exist. That is, you are creating the table if the table does not exist. And the name of the table is contact. And you're saying ID, init, auto increment, primary key. And then first name, voucher 50, not null. Last name, voucher 50, not null. Email address, voucher 100, not null. Unique key on what? With the name what? This is the name of the constraint. On constraint, unique underscore email. On which column? Email column. So you are adding to this email column the unique what? Unique key constraint. And I've told you that what? Be by virtue of creating a unique key constraint. Right? So we are adding to this column, we're adding a unique key to this column, right? Are you there? And by virtue of adding a unique key, what comes with it? A unique index also comes with it. Unique index also comes with it. So by default, when you create a unique key, what happens? A unique index is a follow come, right? Or comes with it, right? Now we have unique and composite index. So what exactly does that mean? So a unique index can be created using create unique index statements, right? Look at an example. Create unique index, debt underscore manager on department underscore on department manager, right? It says a unique index can also be created can also be added to an already created table using the alter table statement. So you can add a constraint, alter table depth, add constraint, depth underscore name underscore UK, unique key on department name. Now, I've told you that what you can create your constraint in several ways. Either when you are creating
Excuse
your
me,
tool.
sir.
Yes.
Excuse me, sir, please. Can you go through that again? Create unique index department underscore. Please, can you just go through that again?
Yes. Create unique index depth underscore manager. That is the name of the unique index that we are creating. Right? Don't mind that I did not put IDX. It does not matter. Right? I didn't put IDX. Usually, what I usually do is I say so that I can identify. I say depth underscore manager underscore UK. UX, sorry. Underscore UX. So this is telling me that it is a unique index, but I didn't put that there, right? But it doesn't matter, right? If I don't put it, it doesn't matter. This is now the name of your. This is the name of your index, and you are adding that index to what? To the manager column on the departments table. That's where you're adding the constraints. I mean the indexes to. So you are creating an index and you're adding it to a table that already exists, right? You created the index and you're adding it to a table that already exists. You can also, of course, when you are creating a table, you can add an index to it. You can add an index. You can add a constraint, and by virtue of adding a constraint, you add an index, right? And also, if you have created the table already and the table does not have an index, you can use the alter table statement to alter the table and add a constraint, right? Can you see? You add a constraint on the column. Can you see? It says alter table depth, add constraint, depth underscore name underscore UK, unique key on depth. Now, by virtue of adding this word constraint, what happens? A unique index is created, right? Those are the two ways to create an index. You either create an index implicitly or you create it what? Explicitly. Implicitly means that when you are creating your table, right? You are creating the constraint. Anytime you create the constraint at this position, in this situation here, this is an implicit index creation. If you look at it, we did not create an index here. What we created or what we added to the table is a constraint. But anytime we say, and we've told you that anytime you create a primary key constraint or a unique key constraint, what happens to it? A primary key index comes or a unique index what comes with them, right? That is an implicit situation. But in this situation, we are creating an explicit situation. That is, we are creating the index by ourselves. We created the index by ourselves and we added the index to the table by ourselves. That is the two different modes. Composite index is an index on multiple columns, right? So when you say you have a composite index, it is one index applying to multiple columns. One index, composite index is the situation where you have one index on multiple columns, right? One index on multiple columns, right? It says MySQL allows you to create a composite index that consists of up to what? 18 columns. That is, you can use one index on about 16 columns. Just one index. So which means that instead of creating, say, index for each column, you can create one index and attach that index to all your columns, right? Now look at it. Create table, right? This is the name of the table. Column 1, data type, primary key. Column 2, data type. Column 3, data type. You now say index name. You are now saying index is attached to this index underscore name is now attached to column 1, column 2, column 3. So which means that on this column, you have two index on the first column. C1 has two indexes. Let's create something. Let's create a composite index so that you can see what I'm talking about. Right? Let's create a composite index. So which database am I on? Let me go to XYZ. Use XYZ. Please let me know if you are following me. Right? And I want to create a table. Create table players. Right? So table players, say player underscore ID is init, is unsigned, is what else do we say? Not null, right? Then we create a primary key, Okay, let's say not null, right? Say not null. Or better, so let's just create a primary key to it. A primary key to that, right? Then F name, right? Virtual. I hope you are following me, right? Virtual 20, 20, not null, right? Last name, virtual 20, not null, right? Email, virtual 50, not null. Phone number, minute, signed, um, position plane, position, jump play, right? Is it a striker? Is it a defender? Is it so we say Vaka 10, not null, right? What else? Right? So I can say index, and I'm saying that let's call the name of the index players underscore IDX, right? Players underscore IDX. Yep, and I attach it to all the columns that I want to attach it to. Say attach it to, use it for first name, last name, email, and position play. Right? Let's run this. Hopefully it will run. Awesome. So it's running. Perfect. So we have, so if we describe players now, right? We describe players now. What do we have? Now, look at it. We have player primary index. Can you see? Can you see? Player as primary index. Email as what? Unique what? Index, right? Email as unique index. So if I come now and I say show index on, from players. Can you see? Look at all the what? Constraints. Look at all the constraints. I did a composite index. I created an index, player underscore IDX, and I added it to 1, 2, 3, 4, 4 columns. Look at them. So the first column is primary key, right? On the table, player's table, and it's attached to player ID, right? And it's a B-tree index. Now look at email. Email as I also created a unique index on a unique constraint on email, and can you see it has a what's it called, and I didn't name it, right? I didn't name that index. That's why it's saying, that's why I said email, right? But that's the name of the index, right? So now I now created a composite index, right? Player underscore IDX, and I added it to name, first name, last name, email, position. Can you see? One single index. Can you see the same name? One single index on 4 different columns. All of them are B-trees. All of them are visible, right? That is how to create an index. One single index on 4 different what? 4 different columns. That is how to create a composite index. Look at it. Unique. That did not. That this is how to add a unique constraint, right? If I want to put the name of the constraint, I'll just say email underscore UK, right? Email underscore UK. That will be the name of the constraint, right? I can also give my primary key a name, say players underscore ID underscore PK, right? So you can give your constraint names. Here, what I did was I have given my constraint a name. If I run this statement again, if I drop that table and I run it again, this is going to be the name of the constraints that I've created, right? So that is how to create, let's try it, drop table layers, right? That's how to drop a table. The table has been dropped, right? If you describe players now, you see that it says that what? The table does not exist. Can you see? The table does not exist. So I want to rerun my statement again to create that table. Error has started. Error has started. What happened? Okay, let's remove this. Hold on, I'm coming. Drop, not null. Hold on, just give me a minute. I'm coming. Just want to check something real quick. Come in. Okay, so all right. So hold on, come in. Just trying to create to show you the different ways of doing that. All right. What I'm trying to do is name my constraint, but doing agidi does not want to collect me. Okay, so this is not working. It's not working. So I return my primary key here, make it work. And then I return my unique key here.
So does that mean you can't name
You can
on
actually. I don't know what is happening. You can actually. You can. I'll work on it. You can.
because I encountered that too. This the last
You can.
assignment.
You know, you can.
Yes.
You can. I think it's the syntax that is wrong. I will look into the syntax again. You can. All right. So that is how to create a composite index. So we created a composite index here, right? And we added it to what? 4 columns at the same time. So you can add a composite index to about 16 columns at the same time. At the same time. At the same time. So I think we should stop here today, so that we can all go and prepare for work tomorrow, right? We can go and prepare for work tomorrow. Any question? So the assignment is this is what I'm going to do. I'm going to develop an assignment and drop it on the group for us so that everybody can see it, right? So I've dropped the assignment in on the group for us, maybe this night or tomorrow, right? Drop the assignment this night or tomorrow on the group. So the assignments would be. I would also um, email everybody that submitted the assignment from the last class or the last assignment. I'll tell you about where you made a mistake, correction you should make, and how to proceed. So I will expect you to make the corrections and resend the assignment so that I can run them and see how far they've gone. Then I'll send you an assignment that would comprise of everything that we've done so far. Alter, create, drop, and all of that and all of that, right? So the pair is going to be about maybe 5 to 10 questions that I'm going to set, right? And that's the only way to know. It's wanting to understand, it's wanting to come to classes, and nothing to be able to practice what we learn in class. Any question before we round up? We have 10 minutes more to go, 10 minutes more to go in this class. Any question before we stop the class? Also, I'll be dropping the video for today's class. I'll drop the link after I've uploaded on YouTube so that we can go through it again. Please and please don't just take the videos and just dump them. Go through them so that you can learn more. The things that you did not understand in class what I'm explaining. You can't understand everything what I'm explaining in class. But when you go through the videos again and you feed on it, you discover that you get more clarity. And of course, you can ask me your questions after you have gone through the videos during the week, either by WhatsApp or by calls or whatever. Even through my emails, you can ask your questions. So, any question?
Yes, sir. Please, sir, I want to ask this unique key, composite key,
Yes.
and primary key constraint. What is really the last one you did now? You just use the composite key.
Yes.
So where are we supposed to use the unique key?
Okay. So, primary keys are to enforce uniqueness of values. That is, they don't allow on this column now that I've added the primary key. Right? What does that mean? It means that the values inside this column are compulsory. That is, this column must have values, and
Yes.
that those values must uniquely identify each row.
Okay.
Unique key, on the other hand, although I said not no, that is compulsory as well, right? But it means that each person must have a unique key. So which means that no two persons must have the same email address,
Okay.
right? The composite index that we created here now is to make the search on any of these columns fast. That is, if I'm searching for a particular data from this table, right? And I use this column, the data in this column, or this column, or this column, or this column, it would make that query run fast. That's the essence of indexes.
Okay.
Do you understand?
Okay, so this
Now,
composite indexes is when you want to do multiple, when you want to run it on multiple columns.
so what
That's
I did with what we do with composite index is that instead of creating indexes for each one of them
Which
separately,
one of them? Okay.
yes, you create one single index
Mm-hmm.
and you apply it to all of them. But these indexes are not clustered index. They are non-clustered index. Do you understand? And what does that mean? It means that we are applying them to these columns, right? And they are used to what? To increase or improve the rate of what? Of query performance on the table, right? The only composite index that you have here is the primary key, which means that it is ingrained, it is ingrained into the what? Into the fiber of the table.
Mm-hmm.
Do you understand what I'm saying?
Yes, yes.
Awesome. Any other question before we wrap up?
Then,
We have 6 minutes.
for the
Yes, ma'am.
assignments, I didn't hear from you. Have you gone through
Yes,
the
I will
assignment?
comment on it. You will get my comment. Don't worry.
Okay, that's all. Thank you.
Yes. All right. Any other person? Any other question?
Fabrice, when are you going to drop this video? Because
This video.
this one you just taught now is kind of technical, so we really need to.
I'll
Because
drop the
this
video. I will try and
unique
drop.
key constraints and all these things, they are kind of confusing, but I'm still going to try and
Don't worry.
listen
Don't let
to
them
it.
be confusing. They are not really confusing. It's just when you watch the video again, you understand it better. That's the way it is.
Okay, sir. Thank
Yeah.
you.
Yes, ma'am. Right. Any other question? I'll be dropping the video. Hopefully, if you don't get the video this night, I'm hoping that I can drop the video this night. If not this night, latest tomorrow. But I'll try and do it this night. Even though I'm very tired, I'll try and do it this night so that we don't miss it. I'll drop it. I'll download it and I'll upload it back to YouTube so that we can have it immediately. Any other question? John, do you have any question? Anoluapo, any question? Vivian, any question?
So, not a question. I was wanting to, if you can clear us, but not now, maybe later, on the problems you encountered while you were adding, naming the, what's it called, the constraints on the code.
The challenge that came with naming the constraint was that it didn't allow me create a constraint. Now, MySQL, like I said, these DBMSs, right, they have their own uniqueness, right? If it was an Oracle database, right, it will allow you create a name for the constraint while you are creating the table, right? But in MySQL, you cannot give a name. I would confirm that now. I'll confirm that though. You cannot give a name to a constraint while creating it. It is when you are adding a constraint to a table using the other statement that you can create a name for it. And it actually emphasizes the essence of a clustered object and a non-clustered object, right? When you create a constraint while you are creating the table, it's a clustered object, right? It means that it is fine-grained, it is ingrained, it is embedded into the table, right? So it is the system that takes charge of the naming of that kind of object. But when you are creating it explicitly, that is using the alter table, right? It means that both of them are different objects that you are stacking upon each other. That way, you have to create the name for it. It allows you to create the name for it. Do you understand?
Yes, sir. Thank you so much.
All right. John, any other question? You wanted to say something?
No, I don't have any question.
Do you understand everything that we've done today?
I'll still have to go through the videos.
All right. Anoluapo, any question? 3 minutes to go. Any question?
No questions.
All right. Do you understand everything we did today?
Not totally. I'll be clear.
All right. Thank you, guys. But like I used to say, you do not have to. We are beginners, right? And you do not have to understand the way I understand present. The concept is what matters, right? The concept is what matters. But the question I need you to ask yourself after we leave classes, this concept that I've learned today, do I understand it enough to be able to apply it to work tomorrow? If somebody brings a work to me and says that alter a table, create a table, alter a table, add constraint, add indexes, will I be able to do this at least to the barest of minimum, something with it? That is how to learn, right? If you want to learn or get to the knowledge level of where I've gotten to, you've forgotten that I've been doing this about 14 years, right? So I've through experience, right, fine-tuned what I know. Do you understand what I'm saying? And that's what I'm pushing to you. And I'm pushing 40 years of experience to you in 3 hours or in over 3 hours, right? You, as much as I want to break it down, right, you cannot understand everything in class, right? But what I usually want you to know or to do is know the basic concept of each of the things that you have done. Know the basic concept of it. Know how to apply them, right? The technicality would come by itself later. Trust me. Trust me. You understand the technicality as you watch the video, as you begin to use them. You begin to see the technicality. But the basic concept is very, very, very important. It's what I want you to get in class. And that's what I want you to answer. If you can answer that to me on the chat, I would also still ask on the WhatsApp group. Everything that we have done, do you understand the basic concept of it? Somebody comes to you tomorrow and say, can you explain what alter table statement means in SQL? Will you be able to explain what it is? Will you be able to, wrap your mind around what it does, create statements and all of that? The basic concept, like I said, is what matters the most, right? So please ask yourself that question. I will ask that question on the group as well, right? And I'm not expecting you to say that, yes, I understand all the concept 100%. No, but to a very good extent, I want to know if you understand the concept, because that is also what I'm going to use to measure my delivery to you guys. I hope you understand what I'm saying. So, thank you for coming to class.
Sorry,
Yes.
no thanks. When we're done with this, right?
Yeah.
We believe, is it possible that we're going to be able to, work independently for, let's say, for a startup, not a company that has an existing database, something?
Yes, that's the essence of the program. The essence of the program is that at the end of this program, right, which I saw, which we did in the last cohort, and we had a success rate of about 92%, right? Almost everybody in that cohort was able to do. They did a project, right, which you're going to do as well. We're going to do a capstone project at the end of this course, and they are able to implement. When you finished on Sunday, they were able to implement on Monday, right? And that is the goal. That is my goal. My goal is that without you going back to your books, right, you can implement the basic concept, right? You understand SQL as a basic concept of data science, data analytics, machine learning, database administrator, SQL developer, whatever role, whatever way you want to apply it, you understand it as a basic concept. You are able to select, you're able to read from a table, you're able to create data, create a schema, create a database, create tables, link up tables together. Just understanding that basic concept is what matters. You are not going to be if I'm going to put it on a scale of 1 to 10, you're not going to be on a 8 or 7. But I expect that at the end of this program, you should be able to be between a 5 and a 6. Do you understand? But practice and more work and the capstone would help you push it to probably about 7 or 8. Do you understand what I'm saying?
Yes, sir. Thank you very much, sir.
Awesome. So that is where we are going to judge each other at the end of the program. That's the way we are going to judge each other. Are you able to do your capstone project by yourself? Are you able to understand the concept after 6 or 7 weeks of SQL? That is how we're going to judge each other, right? And that's why I usually encourage people not to miss class, right? But you can also still watch the videos afterwards. All right. Thank you, people, for coming. Thank you. I really appreciate it. I'm happy that you're trusting me. Even though you don't see me, you still come to class virtually. Thank you, thank you, thank you, thank you, thank you, thank you. Please do your research as well. Don't just take my word for it. Do your research and also learn these things for yourself. Do have a great week. if we have pending discussions, right? I want to see you in my DM, right? If we have pending discussions, right? On let me see you in my DM. All right. Thank you for coming. If you have questions as well, please you can DM me. You can put it on the group as well. Let us talk about it, right? If you have questions, you can DM me and let us talk. All right.
Okay.
Do
Good
have a
night.
great week.
Yeah,
I
good night, sir.
that you will have a great
Good
week.
night,
Bye bye.
sir.
Bye bye, everybody.
Yeah.
Bye.